with a couple of some kind, it's called inverse variation and combined variation. Back in Algebra 1, you did something called direct variation. That might sound familiar to you. Yes or no, I'm not real sure. Christian, do you want to sit here so you can see better? I feel like you have your back to the board. It might be better for you to be able to see. Are you okay? It's up to you, but I just want you to be able to see. But anyway, we're going to do inverse variation today. I want to remind, before we get to inverse variation, what y'all did with direct variation. Maybe this looks familiar to you, maybe it doesn't. Let's take a second and kind of look at what is direct variation, because you're going to have 3 different kinds that you'll need to be able to know. See if this looks familiar to you. Y equals kx. Maybe y equals 3x, y equals 4x, y equals 600x. Yeah, it was a couple years ago, right? And when you graph these functions, all of these functions actually pass through the origin. It depends on whether or not the slope changes. This number here changes the slope, right? And it just kind of goes up or down depending. Does that look familiar to you? Yeah, sort of, yes, but there's no b. The b is 0. And it would just be something, it would say words like y varies directly as x. And that would be kind of like a word problem that you're going to have. But the graph is always going to be a line. So that's something that you did back in Algebra 1. But today we're going to talk about something called inverse variation, and then there's combined variation. We're going to spend more time on inverse variation because it's actually, its graph doesn't look like this. Its graph looks, well, hang on. Well, I'll show you what the graph looks like in a second. I'm having, obviously, some technical difficulties. But let's go ahead. I'll show you what the graph looks like in a few minutes. But let's go ahead and think about what is a constant term, okay? So cross out the expressions that do not have, or that do not contain a constant term. So you don't have to write this down, but just kind of pay attention. Does this one have a constant?
Yeah.
What is it? 5. Good. Okay, so it has a constant term. How about the next one? Any constants? No, so we're going to cross it out. How about this one? Ooh, 2 is a constant, I agree. But look at where that x is in the denominator, isn't it? And that's what we're going to be dealing with today, okay? Our variables are going to be in the denominator of our fractions. How about this one? Does it have a constant?
No.
Actually, that's a z. It looks like a 2, but it's a z, okay? So it does not have a constant either. But we know what constant means. What's a constant in this variable, in this expression right here? 1. So we know what a constant is. It's a number that doesn't have a variable with it, right? Okay. Well, let's talk today, and I want you to add this to your notes that you took on combined variation. So go ahead and add this little box right here, inverse variation, to your notes. So right underneath where you have the combined variation, add this one. And it's your inverse variation. Y equals kx. And this is really, let me try to make it a little bit bigger so you guys can really see, because there's a couple of different things that are on here. Let me make it a little bigger. There we go. Okay, so this is what I want you to add to your notes, right here. Okay? Now, y equals kx is often what I use, just that portion there. There are other ways to write it. You could also say xy equals k. I don't typically use that as much. Or you could say x equals k over y. The one that I've highlighted is really the one that we tend to use. And it's going to say something like y varies inversely as x. And so that's what I want you to write. What I've highlighted here, the sentence that goes along with it is y varies inversely as x. Okay? So when you see that term or that sentence, the word inversely means that this is the formula that I'm going to be using. If it said y varies directly as x, what would the formula be? It would be y equals kx. Notice the difference. If it says y varies directly as x, it's y equals kx. If it says y varies inversely as x, it's y equals k divided by x. Okay, the word directly, the word inversely just means two different formulas, that's all. Okay? So, the main idea here when we talk about an inverse variation is that two quantities, x and y, the two variables, vary inversely when one increases and the other decreases. What's going to happen when we talk about direct variation? As one increases, as x gets bigger, what's happening to y? As x goes to infinity, what's y doing? So isn't it going, they both go up, don't they? As x goes up, y goes up. That's direct variation. When we talk about inverse variation, one's going to go up and one's going to go down. Okay? So as x goes to infinity, what's y going to do? It's going to go down. Let's try to plug in a graph for a second. Let's go ahead and get your calculators out, and let's graph a couple of these inverse variations. Let me give you a couple to try. Y equals 2 divided by x. What does the shape of an inverse variation graph look like? So go ahead and plug it in. 2 divided by x. So in your calculator, tell me what you think. Does it look like a line like the direct variation did? It shouldn't. It should look different. So 2 divided by x. We're just going to zoom a standard window. And we have didn't we graph one like this back when we did parent graphs, the very, very beginning of the year? Huh? Yeah. So this right here is an inverse variation graph. Okay? As x goes to infinity, y goes down, doesn't it? As x goes to negative infinity, y is going up. Okay? So as one goes up, one goes down. It's basically what we want to remember with this. Okay? All right. So
the inverse?
That's with the inverse. Direct, they both go up or they both go down. Okay? Good. So let's go ahead and think about some of these questions, true or false. You don't need to write these down yet. As the radius of a pizza increases, okay, so kind of imagine that. The radius is going to increase. The circumference of the pizza also increases. This is a direct variation. That's true. They're both increasing, right? So that's true. I agree. As the number of miles a car is driven increases, the number of gallons of gas in the car's tank decreases. That is an inverse variation. One's going up, one's going down. True. As the number of pages in a book increases, the weight of the book increases. This is an inverse variation. What is it? It's a direct variation. Good. Good. Put them on my desk, Will. Okay. So let's look at an example here, okay, and decide, is this an inverse variation or a direct variation? So let's look here. What's happening to the x? Is x increasing or is x decreasing? It's going up. Would you agree with that? So as x increases, what's happening to y? It's also increasing, isn't it? So that's going to be possibly a direct. It's definitely not inverse. Would you agree with that? Okay, good. Let's figure out an inverse variation. This is one I want you to write down in your notes. So write down the problem for me. Okay. I'll highlight the part that's important to write down. And this is what we're going to be working on in terms of the problems that we're going to be doing. Okay? So it's good to have an example in your notes. What's a key word in the problem? Inversely. Varies inversely, key words. Okay? So I'm actually, because they're key words, I'm going to highlight them a little differently so we know. Varies inversely. So because of that, what formula am I going to use right away? Which one am I going to use? y equals k over x, which I don't see up here. So I'm just going to write it. Okay? They actually have this one, which is the same thing. Either of these two are okay, but because I only want you to memorize one formula, let's just do one. Okay? Is that okay with you, rather than having to memorize a bunch of them? So this is the one that we'll stick with. Right? Just remember one thing. Okay? So let's go ahead. I'm sorry, baby? You do. That's your inverse variation. Your direct is y equals kx. All right. So it says that we have a couple of numbers. Notice we have x equals 8 and y equals -7. So what we want to do is use those two numbers to solve for k. K is called our constant of variation. And you notice you have a k in the direct, y equals kx, and you have it in the inverse. So we need to solve for k. Because remember how when we plugged it into our calculator, we plugged in y equals 2 divided by x? Or y equals 3 divided by x? That 2 or that 3 is your constant of variation. So we need to find this number here. So notice if I plug in an 8 into my equation and a -7, we'll be able to do that. So I'm going to have -7 equals k divided by 8. Just literally plugging in the numbers that it gives us. How would I solve this for k, Travis? By what? Perfect. I'm going to multiply both sides by 8. It's exactly what I'm going to do. Multiply by 8, multiply by 8. So what is my constant of variation? -56, right? Good. The equation, so we solved for k, we did that. And what the question says is find the model, which means an equation. So the equation is just going to be y equals -56 over all I did was solve for k. So y equals -56 over x. That's just the equation. Okay, that's the model. Once I have the model, I can be asked lots of questions. What's the value when x equals 4? Let's find it. We have the model now. So what is y when x equals 4? How would I solve that? Not in place of y, we're trying to find y. What is y? We're going to plug 4 in for x. So y equals -56 divided by 4. What is that number? You have a calculator? 56 divided by 4. I get -14. So once I have the model, I can be asked lots of questions, right? So we always want to find our constant of variation, then our model, and then we can answer whatever questions we need to. So it's kind of like a 3-step process. Find k, find your model, and then answer the question. Okay? It's really that same 3 steps almost every time, Natalia. Okay? I know you're sleepy. It's the first time you've been at school before 8 o'clock in weeks, it feels like. Did anyone get up and check too, like I did? I got up and I'm like, really? On time? For real? All right, I did. So let's look at it, a real life situation, a problem that would deal with this kind of thing. We already know a couple of scenarios that would be inverse variation. Give me one that we talked about at the beginning of class. Inverse variation. What was one of the models that we did? As something gets bigger, what gets smaller? Give me an example, though. What were some of the scenarios in the beginning of class that we did? Good. As your miles increase, the amount of gas you have decreases. That's an example of an inverse variation. Here's another one. After a major snowstorm, I'm saying snow because we just had it, okay, our class is going to volunteer to remove snow from yards. We're awesome, right? No, because we're volunteering and we're being good community servants. Okay. Okay. The table here, what we have, shows the time in minutes that it takes a group of a certain size of students to remove the snow from the driveway. So let's see if this is an inverse or a direct variation. As the number of students increase, what happens to the time it takes to remove the snow? So is it inverse? Okay, so it looks like as one goes up, one goes down. So it does look inverse to me. So let's go and answer the questions. The less time it takes, the more students who work. It's one goes up, one goes down. So an inverse variation seems appropriate. So what is the equation that we want to find? Well, we have to test the data. If we're trying to figure out if we have some information here, if I multiply these two things, okay, we're trying to figure it out. What is 225 times 1?
225.
Okay.
Well, what are we looking for?
So let's look. We're looking for k. Y equals k. Y equals k divided by x. That's our inverse variation. Do you agree?
Well, what's the question?
Hang on. I'm going to show you. I'm trying to find a model. So isn't k equal to xy? So if I just multiply x times y, I'm going to find approximately what k is. Okay? So 225. Let's see if it works. What's 75 times 3? Try again. What's 75 times 3? 225. What's 45 times 5? So it's approximately 225 in each case. Would you agree? So the product is approximately 225. So that is k. Would you agree? Okay. So my equation is going to be the time it takes is equal to 225 over the number of students we have. You could just, if the t and the n bother you, I'm okay with you just saying y equals 225 divided by n. Okay? I'm sorry, divided by x. If you want to keep with the y and the x, that's fine with me. All right? But I just wrote t and n for time and number of students just so we have it in context of the problem. Okay? All we did was found k because we were given a table, a little bit different. If that bothers you, we can do it just like what we did before. Remember what we did over here in this problem. We picked an x, we picked a y, didn't we? And we plugged it into our equation to solve for k. I can do that exact same thing here. Which x and which y do you want to pick? Let's pick 5 and 45. I don't care. Let's do that. So we're going to say y equals k over x is our model. Let's pick k over 5. What's y? 45. Travis, what do I do to solve for k? Multiply by 5. What's 45 times 5? That's how I knew I got 225. So if you want to do that, great. Okay? So we wrote the model. So the equation, go ahead. So it just says what function models. All we wanted was the model. Do we get the model yet? Question first. Because I multiplied 225 times 1, 75 times 3. Okay. I know that's what is confusing. Y equals k divided by x is the model, right? But in order to figure out k, what did I have to do? I had to multiply both sides. That's why it was the product. Okay?
Well, my question is, how do we know what to plug in t for y and n for students?
The first one is your x, and the second one is your y. Good question. One is dependent on the other. The time it takes depends on the number of students you have. So if it depends on it, it's your y. X is your independent variable. Think about science. Okay? All right, so all we wanted was a model. Did we achieve that? Did we get a model? Okay, so I'm going to ask you a question based on this model. How long would it take if we had a class of, how many of us, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 29, okay? So if all 29 of us went, how long would it take? Tell me what I do. Tell me what I do. Answer the question. For x or y? Okay. We want the number of people, so we're going to plug in 29. So what is y equals 225 divided by 29? How long is it going to take us to clear a yard? I don't know, the yards. Oh, 29, sorry. So 7 minutes. 7.75 minutes. 7 minutes and, I don't know, almost 8 minutes.
Probably 8 because I'm getting the gas station.
Getting some snow shovels? Perfect. Okay. All right. As one goes up, one goes down. Good. Again, we're just solving for our constant of variation and plugging it in. All right. I'm going to pause for a second before we get to our combined variations, which is what you wrote down. So let me go ahead and pass something out for you first. So let's do one like problems 1 through 6. Does it bother you about the fractions? On the calculator, which you're able to use, do you know how to plug in fractions? So just use your calculator. Don't worry about the fractions. Okay? Let's do one together. Let's do number 5, so it has a little bit of fractions in it. Okay? So I'm going to do one of each type together with you. So let's start with number 5. We have a point. The point is 2 1/3. And it says, each ordered pair is from an inverse variation. Find the constant of variation. So we know it's from an inverse. So we know it's from y equals k divided by x. Do you agree? Do I have an x? Do I have a y? Can I plug it in to find k? So 1/3 equals k divided by 2. Travis, what do I do to both sides to solve for k? Multiply by 2. Yep. So k is equal to 2 times 1/3. On the calculator, you can just put parentheses around your 1 divided by 3, or you can go ahead and do your alpha y equals 2 times 1/3. 0.6 repeating is the same thing as 2/3. So k is equal to either 0.6 repeating or 2/3. I will be okay with either of those.
That's the answer?
That's the answer. You found the constant of variation. Not difficult. Okay? Again, you do not have enough room on here to show your work.
There's a pattern right here. Where is it?
Oh, make it fit.
So we'll worry about the puzzle when, and the, yeah, 2/3 is down there. 0.6 repeating.
Oh, it's 2/3.
Isn't it 2/3?
Yeah, it's 2/3, but
Oh, I don't see a positive 2/3, do you? I see a negative 2/3. It's definitely not negative. All right, we'll have to, maybe there's an error. We'll have to look. I'll look at the answer key and we'll see, okay? But there's a puzzle part at the bottom, and Tim was looking at the answer choices, and I agree with him. I don't see a positive 2/3, so maybe there was a typo, which is possible. I'll look at it. But let's go ahead and look at the next section. We're going to do all of this. We're going to do everything 1 through 16 right now, and then we'll get to the joint variation in a minute, or the combined.
You're wonderful, man.
Thank you. All right, 7 through 12. I'm going to do problem 11. Number 11, we say suppose that x and y vary inversely. If it varies inversely, aren't we here? Okay. It says 11 on the board. Again, it says find the constant of variation. So all we need is k. Do I have an x and do I have a y? Am I given that in number 11? So aren't I just plugging it in? It's really, I mean, do I have to do that? That's pretty easy, right? Okay. It's when I get to a problem like 13 through 16 that it becomes a little bit more difficult. Okay? So it says find the missing value. So let's do one like number 13. It says we have 2 ordered pairs that are from an inverse variation. We need to find the missing value. So think about the 3 steps I told you. The first one is always to find what? Your constant. And then I'm going to find, once I have my constant, I'm going to create a model. Once I have a model, then I'm going to solve for what I'm looking for. So that's my 3 steps. Again, first find our constant of variation. Second, I'm going to create a model. And third, I'm going to find what I'm looking for. In this case, we're going to find y. Okay? How can I find k with my given information?
You do the little,
With which, Oshemi, you knew what it was. I used 2 and 6. Good. I'm going to use the first point to find my k. So y equals k divided by x. It's inverse. 6 equals 2, I'm sorry, k over 2. Chris, you're going to start doing what I asked you to do, which is write this down. Let's be respectful to everyone in the room. Okay? I just used my 2 and my 6. I plugged a 6 in for y and a 2 in for x. And now I have to multiply both sides by 2 to get rid of the k, and k is 12. So I've done step 1. I found k. What's step 2? Find a model. What's my model? Good. So I found k. Now I've got my model. So now I need to find what I'm looking for. I'm going to use the model I created to find my y. I'm looking for this. So in this case, I'm going to say y equals 12 divided by negative 4. What's y? Negative 3. That's what I'm looking for. Because 12 divided by negative 4.
Oh, okay.
It's plugged in the negative 4 into my model. Created my model.
So that negative 4 is a P core?
No, that negative 4 is what I had to plug in to my model.
So that's the edge.
That's how I found my answer. Okay? Find k, find your model, use the next part to find the remaining step. Okay?
Not trying to look for the one that you chose. That's on the board.
The ones that are on the board, that's okay. But the other ones you need to. Okay? Now, once you, on 1 through 16, once you figured out the answers, go down at the bottom and use the puzzle to create and fill in the blanks at the bottom. Okay? And I will double check on that 2/3 one because it looks to me like there might have been a typo, but I'll check. So I'll pause this for a minute. We are going to come back to the combined and joint variation in just a second. So I did just check the answer key. So number 5, that should be a negative 1/3, which will give us a negative 2/3 as our answer. So please add that. It just was a typo on the actual worksheet itself, okay? I'll double check. Hopefully there won't be any other typos. A little bit more difficult to solve. Can I show you something real quick? Jennifer just brought something to my attention. If I have something like this, 2 equals 3 divided by x. It's not those exact numbers. But let's say I have to solve this for x. How would I do that? How do I solve? Look, everyone should look at this. I'm not going to answer the question more than once if you're not paying attention.
You do it the same way you would do it.
How do I solve that for x?
Multiply by 3.
I don't multiply by 3. I don't divide by 3 either. I multiply by x. So then I have 2x equals 3. Now I divide by 2. It's a 2-step problem. It's one of the problems towards the bottom. You have the x on the bottom that you have to solve for. There's 2 of them like that? Okay. I wanted to make sure we remembered how to solve for x when it is in the denominator of a fraction. It requires 2 steps to get there. Okay? So there is another kind of variation that we need to talk about, and it's when you combine several different variations together. You can combine a joint variation, joint variation is one of them, a direct variation with an inverse variation, etc. So we have to kind of look at these formulas, and you went ahead and wrote them in your notes already. So I want everybody's eyeballs up, pens down for a minute, because you've already written this down. So I want pens down, Raul. I just want you to look up here for me, okay? You have written this down already, or should have, and Nate, you will and show it to me for a late grade, right? Same with you, Trent, right? Okay. So notice it says Z varies jointly. Now, keyword I'm going to highlight, and you should probably circle in your own notes the keywords as well. Jointly, jointly inversely, jointly inversely. Okay? So you need to think about those as being keywords. Inversely, we know what that means. We're going to be dividing by our variable, whatever it's inversely as. Notice in the first one it says jointly. Notice what the equation looks like. Doesn't it kind of look like a direct variation equation? Y equals k times something. It's jointly with both x and y. So z varies, z equals kxy. K is always our constant of variation. So I'm just going to highlight k every time. It's a constant. We need to find that k every time. Isn't our process find k, find a model, solve the problem? So we're still going to continue to solve for k every time. So z equals some number k, xy. So this time you're going to be given an x, a y, and a z to be able to solve. Again, jointly means you multiply them all together. Jointly with x and y, inversely with w. So again, we have a k in there. Z varies. Jointly with x and y. Why is w in the denominator? Because that's what the inversely means. Okay? So inversely means divide by w. Jointly with x and inversely with the product yw. Does it make sense that wy is in the denominator? Because that's what follows the inversely part. Okay? So let's look at these next three right here and just kind of fill in the letters. This equation, P equals Km. P varies jointly with T and, I think that's an N, right? T and N. Over here, M varies jointly with which variable? Y. And inversely with the product Xn. Let's try this one. V varies, notice there's always a K, jointly with what? R and M. Jointly means it's in the numerator. Inversely with Z. So we should be able to take these sentences and create an equation. Okay? So let's look at problem 17. Okay, we'll do 17 together, and then you're going to do the others. 17 says Z varies jointly with X and Y. What's the equation that goes with that? Z varies, so what does that mean? Z equals K, and then we have KXY. Good. Okay, that's the equation that goes with 17. Z varies, Z equals K. K is always going to be there because we have to solve for our constant of variation, which we need to do. It actually says, well, let's write our steps down again. 1 is to find K. 2 is to create a model. And 3 is to solve the problem. So I need to find K. Do I have any information in 17 that will help me find K?
Yes.
What information do I have?
X equals -8.
So in X, I'm going to plug in a -8. Do I have a Y value?
Yes.
-3. And do I have a Z value? So I'm just literally plugging in the values it gives me into the equation to solve for K. That's all I'm doing.
That was for
Make sure you understand where the green equation came from. Right, it came from the sentence, right?
So why don't we pick that one?
Why do we pick what one? Because we just had to write the equation that follows what it says to do. I'm just literally just using algebra and writing down the equation it tells me to write. So now I'm going to solve for K. What is -8 times -3? Positive 24. I need to solve for K. How do I get it alone? K is not 4, by the way. Divide by 24. What is 6 divided by 24? 0.25. Now, you can leave it as 0.25. You can write it as a fraction. Either way is okay. I don't care. So I found my k. What's my next step? Find a model. So I'm going to use the green again, and rather than write k, I'm just going to write 0.25. Do I have a model now? Got a model. Now I have to solve. If you look at question 17, it says find, in the bold highlight above it, do you see that? And look at the problem. Doesn't, in the bold highlight, find z when x equals 2 and y equals 10. Do you see that? So that's the solve part. So it says find z when x equals 2 and y equals 10. So I'm going to multiply all those together. 0.25 times 2 times 10. And I get 5. So the answer to number 17 is 5. Okay? So problems 18 and 19 I'm going to leave you to do. This is the same process you're going to do. The only thing that may be different is this equation I'm highlighting in purple, because it depends on what the question says. In number 18, what's the equation going to be that I'm going to use to solve for k? Z varies directly with x and inversely with y. What's 18's equation going to be? Right. So in 18, you're going to start with z varies directly with x. So where does x go?
It goes
Kx
over y.
over y. Good. That's what we're going to start with in 18. How about in 19? Z varies directly. So z varies directly with the square of y and inversely with x. So those are the equations to start with 18 and 19. You're going to use the same process. Find k, use the numbers that are given to you in the problem, plug them in like we did here in blue, find k. Then you're going to create your model. And then you're going to solve by plugging in your 2 and your 10 for x and y. Okay? So go ahead, when you're finished with this, turn it in. It is going to be a graded assignment for you today. You are going to have a separate homework assignment from your textbook. Okay? So when you're done, turn it in. All right, guys, here is your homework, just so you know. Okay? I'll write it up here. I'll text it to you, and I'll also put it on School Fusion. But the classwork is to be turned in before you leave today. You got about 10 more minutes, okay? Okay?